Okay, great. So, hello everyone. Today we will be doing our final report presentation. Our project is about a humidity and heat control system. Basically, what we wanted to do is to take a day-to-day device that we use every day and add to it some engineering intelligence and make it more smart that can be suitable to be present in this year, 2020. Our day-to-day device that we use for air conditioning, humidity control, etc. All of these devices are traditional devices that does not have the user interference technology, which means every device that we use in our household have some pre-installed settings. Basically, if you want to turn the air conditioner on, the air conditioner does not measure the temperature in the room. Rather, it just work on a specific workload that would produce air temperature for specific on specific temperature, which means that the room itself can have a different temperature, and the air conditioner can be producing air in a different temperature. What we wanted to do is to make that more balanced, and we wanted to make sure that the room temperature is always controlled. Thus, we installed the sensors to a normal air conditioning system. So basically, we will be focusing on controlling humidity and controlling temperature, along with increasing efficiency. Any household can actually have an air conditioner. Some households have humidity controlling devices, and some even have some air purifiers, which make the air more clean and more healthier. So our device will have two parts, and our new idea, the idea that we invented, my team and I, is the brain. So we will be adding sensors and microprocessors along with a detailed code that will interfere between the environment and the device itself. The devices can be in the body, an air conditioner, a dehumidifier, and air purifier. Actually, any device that can control or affect the environment can be added to the body, and certain adjustments can be done to the brain. So we started off by a prototype edition. A prototype edition where we can actually test the theory that we have presented and create a small device that can illustrate or demonstrate how a mass production product can look like. So for that prototype, we will be using the ultrasonic sensor, which is a sensor that can see how far an object is from the sensor itself and can somehow measure or see the environment around us. So basically, the ultrasonic sensor would be our eyes for the device itself. And a thermal humidity, it's a sensor that measures the humidity in the room or in the atmosphere. And then we have transformed into some higher quality sensors, sensors that are actually quite that actually have a lot of high standards that can be used in a lot of big industries. For example, we have the humidity sensor. This specific one have its usage in the chemical industry and physical industry, and it still remains somehow acceptable price range. So it's a high quality sensor, and as you can see, sir, in the report, there's a lot more data about it. It's a very good sensor. And we also have the ultrasonic sensor, which also lies between a very poor quality sensor and a very high quality sensor. We wanted to find someone in between because ultrasonic sensors can get very expensive. Some actually consumer drones have sensors that price range between $100 and $200, which can be expensive for our device and for a mass production entity. Again, we have the external body parts for testing the hypothesis of our idea and our project. We wanted to have devices that we can actually test on, and so basically we picked some random devices on the internet. We have studied their price range, their capacity, their voltage input, etc. And these are the devices we have picked. There's a dehumidifier which reduces the humidity and the H2O particles in the air. And there's the air conditioner, the normal one that we use in our homes, and there is an air purifier. And this device specifically is used for people with allergies and people who want to make their home a more clean environment. And it can also be a smoke against smoke. It can work against smoke. So basically, if there's somebody who smokes and want to get rid of the smoke stuff, they can use this device to make it go away. And there's a humidifier because, for example, in winter when we close our windows and we turn our heaters on, the temperature, or let's say the air in the room can get very dry, and that's actually unhealthy for us. And so for some situations, a humidifier is needed to increase the H2O percentage in the air. And now we can move to my friend Musab. Musab?
Yes, can you hear me, guys?
Musab?
Hello, can you hear me?
Yeah.
Okay, so hello guys. My name is Musab. I will go into deeper technical stuff right now. So please focus here. We have two references. We're controlling the humidity and the temperature. Because as we said, it's the most efficient way of controlling temperature, to control the humidity with it. And at the same time, we want to balance a good, healthy humidity rate in the room. So first, we're going through the humidity reference, which comes from the sensors, and it's an input for the controller that you can see that at the top right, and it measures the error. And according to the error, we set for example, the relative humidity for, let's say, 40 to 50%, which is the pretty comfortable humidity level. And then if the humidity is under 40% or 35%, the humidifier will work, and it will give a signal for the humidifier to work. Thus, the humidifier will increase the humidity, and we will have again a signal that will feed the error. So I don't want to make it to a control class. I just want to explain how it works. And if the humidity is over 60% or 50%, we will have the dehumidifier working, bringing back the normal humidity levels to the normal, which can also work just by turning on the dehumidifier. Same goes for the temperature reference down in number 2. You can see that we are measuring by the same humidity sensor. It can also measures the temperature, and it will give a feedback to the error. The error will measures, for example, how many degrees is the difference between the required temperature and the actual temperature. And according to that, it will turn on the heater in the air condition or the cooler in the air condition. uh, and our error will become smaller and smaller until we get our desired temperature. Can you go on, Sonia? So now I want to speak widely about our system and why did we choose this system. First of all, thanks for the previous group, Mr. Volkan, Hakan, Seda, and Eda. They explained pretty much the situation we are having. We're having some high humidity levels, and it takes a lot of energy, and most of our electrical bills are from the air conditions. So when we control the weather and the humidity together, it's more efficient to decrease our electrical bill and live in a more comfortable environment. And of course, if we save from our electrical bill, we can go to the cinema, we can enjoy our life with the money, with the extra money we will have. That's the very obvious thing. We have high humidity. This will protect from oxidation and stuff. And this is a CAD design that we made. It represents a prototype that can be for home applications. So for the home application, we chose it. With the wheels and stepper motor, so that we can. This same device you can buy only one for your home, and this device and the home and clean every room and set its humidity and temperature. By the way, that's only this device includes the sensors, so it detects each room and goes to the other room. It's cheap for homes, small, and now I can show you the mass production edition we made. So this one is more expensive. It has a UV light, so it can kill viruses and stuff. It also can move, but it can move in one big, for example, let's say a factory or something. So it can control all of this factory in one time. And now we go to the effects. So the effects is pretty much so annoying for girls, especially for their hair. When you have high humidity, all the girls know this fuzzy hair problem that happens with high humidity, especially in winter. And that's because of the hydrogen atoms bonding between the water molecules and the proteins that are in your hair, because everyone's hair has protein. And one of the reasons I cut my hair is that we are having very high humidity, and I don't have a humidity controller at my home. So also we have allergy. People who suffers from any kind of allergy like those also can because the allergy is basically by these kinds of pollen, and these pollen are cleaned by the air purifier we are putting in the system. So people who suffers from allergy can also buy our system. But what about greater deals? That was just fuzzy hair and allergy. I mean, you can take antihistamine for allergy. But what about things that should be controlled? We can't offer not to control them. And this includes asthma, people who suffers from asthma, because people with asthma suffers from moist air, because moist air is heavier, because moist air includes more water particles and thus more humidity. And we need to make breathing easier for them. So lowering humidity is good for them. Also from cystic fibrosis, these people, as you can see in the image, suffers from mucus that are inside their lungs. You see, this mucus can attract any bacteria, or smoke or any particles that are in the air, and thus they need easy air to breathe, which is relative low humidity. And of course, the virus that everyone is currently suffering from, corona, it's proven to be spread by humid air, and in general, viruses live longer in humid air. Why? Because there are water particles that they can attach on. So prevent yourself from corona. It's proven also that corona lives less, relatively not very dry conditions. So also not very dry condition can cause the corona to live less, which is better for us, which lowers our risk from catching corona. These are a series of tasks and roles we chose to put and show, which we will have in our project: heat control, humidity control, circuit design, Arduino programming, and we depended on that. The reference for us was the ISO and health standards, and we also focused on maximizing the efficiency and making it the most efficient, most possibly efficient system. That was our presentation. Thank you for listening. Ojam, if you have any questions, please let me know.
Thank you very much for the presentation. Can you open just the last slide? Musab, can you open the last one? Last slide.
Osama is now opening. Osama, please.
Sharing. He is not online, so I'm making you the presenter. Okay. Okay. So, okay. This one. Yes, yes. I'm talking about us. Thank you very much. By the way, first of all, that's a good project. You are using your innovation to update and create a new system to the current, an alternative to the current systems online. But my question, okay, that's a very good idea. First of all, as I told you, so that's the project. Thank you very much. But I have questions. So you have included, you have shown the block diagrams you have made for humidity and temperature control. But well, okay, that part is fine. But you should be maybe about for future improvements. You should be thinking about adding maybe a virus detection, etc. But more importantly, sensor locations and calculations are missing in your presentation. I hope they are valid on the project, because there should be, okay, that's an engineering project, and you should be approving that which sensors and why you have selected in your design. Okay. Did you do it in your project? Because I'm going to start the project. I'm going to start reading the projects after the presentations for sure. First, I want to listen to your presentations. So if not, you can update still your project till Friday. That's for everybody. With the same name, you should be writing like updated. You should be mentioning updated. Other than that, I can grade the early one, the first one. So you have an opportunity to update your project if those places are missing. Because I can see the circuit design, Arduino programming, and the selection of components, in this case sensors, in this test, they were not exactly there in the presentation, right? Because there were some prototypes, I think they don't belong to you. So you are showing some references, that's normal, but you should be proposing the number of sensors or the locations or why you have selected these sensors, including the data sheets for sure. I remember that Osama has shown a sensor, one or two sensors with serials or the product names. But more importantly, we are not dealing with the product names. But more importantly, you should be showing the data sheets, the ranks of the sensors, or the transfer functions. You remember during the lectures we are focused on the transfer working range, etc. These details are important because this year a company might be not interested in the company name, but the technical data sheets. Because today Siemens might be developing a company, developing a sensor, manufacturing a sensor. Next year it may be your sensor, okay, or somebody else's manufacturing, which means I'm interested on the data sheets and how you have selected those.
Okay, Hocam,
We have presented the data sheet and all the needed information in the final report. Also, it's mentioned in the reference. So we have found actually we have found technical data. We have found like very detailed features and technical data for each sensor, and based on that we have chosen the sensors.
Okay.
and also,
So it's mentioned
Hocam,
in the final report.
So if they're on the report, no problem. It will be fine. But please, from now on, for the rest of the teams, please don't forget to show your work in the presentation, during the presentation. I repeat this because for sure I'm going to read the projects. If these points, like the calculations and the correct like the methods or why you have selected those components, those sensors, and what exactly are those? What are their data sheets? If you have shown them in your report, that's fine. For the following, Musab, I'm going to give you a chance, just a minute. For sure, during the presentation, you can show those details. Okay, these are important facts that convincing the audience. Okay, you have you know what you are proposing exactly, and you have worked on it well enough. Okay, that's why we are having proposals, presentations. Sorry. Other than that, we'll need no presentations that I could read the reports and grade them. Okay, and for your that's important for your future project proposals, because in real life you are going to be presenting your ideas or your engineering work to some people. Yeah, what's up, please?
yes, Hocam, you commented on three things. First, the data sheets. I don't think it's a great idea to present them in the presentation because nobody will read the data sheet in the presentation. I think that it's better to present it in the
Why?
that we uploaded, and we did that. And you asked why did we select these sensors? We selected them because they had the perfect precision and accuracy. So our main focus was precision and accuracy.
Those are the details
which we needed for our system to work. Yes, those details are found by numbers in the research we did. In the project, you can find them that we uploaded. And you also mentioned the question about the locations of these sensors. They are very obvious in the CAD design. Osama, if you just can go back to the CAD design.
Sorry, what is obvious? Okay, that one.
Yes. So here you can see the position of the humidity sensor and the temperature sensor and the ultrasonic sensor. They're obvious here.
In this case, you should be showing, because you are engineers, okay? You are not just CAD designers. That's the difference of an engineer and a CAD designer. You should be selecting the correct components and showing them, and show why you have selected those components. There should be a calculation behind. As I told you to the previous group, you can be referencing to other studies. Okay, they have done this, and we have made a similar approach, and we have used something similar. But still, if that's on your report, no problem. So I want to see during the presentations a little bit talk about why you have selected those sensors, because there are numbers and numbers of humidity sensors and temperature sensors. So you should be at least during the presentation, for sure it should be valid on the project, but during the presentation I expect to hear why you have, yes, exactly like this, why you have selected these ones. At least the data sheet should be, I remember this one, that looks fine, but at least the data sheet should be better for convincing the audience. Understand my comments, my points?
Yes, yes, exactly.
Okay.
Yes, sir.
So, thank you very much. That's a good project. And I'm going to be reading the document you have uploaded. But keep in mind that for future presentations of yours in the university or after you graduate, you are engineers and you should be showing people what exactly your, it's not under a patent, information, intellectual property, etc. You should be convincing people that, okay, we are using these because the transfer function is working for us properly, etc. Okay? That's not a serial production commercial. You should be giving data. Okay?
Okay.
Thank you very much. Good
Okay.
project.
Thanks so
Thanks for listening.
much.
Okay. So the next team, Elif Perşem Avşar. Okay. Are you ready?
Evet hocam. Ben paylaşacağım şey.
Sunumu kim yapıyor?
Ben Ekin.
Tamam. Tamam. Seni o zaman presenter yapıyorum. Tamam. Takımın geri kalanında bir ekran kameraları açıp herkese kendilerini tanıtırsa oradan sonra başlayabilirsiniz. Kimler var takımda sizin?
Kamerayı açamadım.
Hı hı. Selamlar. Selam Beyza.
Merhaba hocam.
Nasılsınız? Her şey yolunda mı?
Çok şükür.
Tamam, güzel. Tamam. 4 kişiydiniz değil mi? Hande hoş geldin.